Alright, for this next problem, we're using the mean value theorem. So I'm going to plug in 1, I'm going to get the answer of -2. I'm going to plug in -2. And see what we get. We get -8. So what I'm going to do here is I'm going to take the slope. So -2 minus -8 over 1 minus -2 gives me 6 over 3, which is equal to 2. So when I take the derivative, 3x squared minus 2x minus 2 equals 2. I'm going to subtract the 2 to the other side. This time I'm going to figure out where they intersect by plugging in y1 equals 3x squared minus 2x minus 4. And I'm going to plug y2 equals 0. And there's two intersections. One is at -0.86 and the other one is at 1.53, and because I need to be in between -2 and 1, the only answer I get is -0.86. For this next problem, I'm going to plug in 2, and I get 0, and I plug in -7, and I get the answer of 3. So 0 minus 3 equals 2 minus -7, which equals -3 over 9, or -1/3. When I take the derivative and treat this like 2 minus x to the 1/2 power, so I get 1/2 2 minus x to the -1/2 power times -1, or -1 over 2 square roots of 2 minus x, which I'm then going to set equal to -1/3. By multiplying by -1 on both sides, those two negatives can go away. And I'm going to cross multiply just to get rid of these fractions, or we could just take the reciprocal of both sides. Then I'm going to divide by 2. So this turns out to be 3 over 2 equals square root of 2 minus x, so that when I square both sides, I get 9/4 equals 2 minus x. Subtract 2 on both sides, 1/4 equals -x, which means x is equal to -1/4, and that is the answer for my mean value theorem application. So when I take the derivative here, in order to find out where this is increasing and decreasing, I get 4x to the third minus 4x. And I need to set this equal to 0. So I factor out what they have in common, which is a 4x. And then when I factor out the parenthesis, I wind up with x equals 0, x equals -1, and x equals +1. So I'm going to make my chart. From -infinity to -1, from -1 to 0, from 0 to 1, from 1 to infinity. And so I need a test point. -2, -0.5, +0.5, and 1.5. And so when I plug it into, let's say, this portion where I have it all factored down, when I plug in -2, I got a negative, a negative, a negative, which is 3 negatives, so that means it's negative, which means we are decreasing. When I plug in -0.5, I got a negative. When I add 1, it's a positive. When I subtract 1, it's still negative, so 2 negatives means this is positive, which means I am increasing. When I plug in 0.5, the first one's positive. When I add 1, it's positive. When I subtract 1, it's negative. So that means that part is decreasing. And when I plug in 1.5, all of my factors are positive. So this portion is increasing. Alright, so for this one, we're going to use the product formula again. So the derivative of this would be 2 times x plus 2 times 1, but I'm not going to write that down. The derivative of the second part is just 1. So I got x plus 2 squared plus 2 times x plus 2 times x minus 1. Once again, like in the other problem that we did similar, they have an x plus 2 in common. The first part has an x plus 2 left. The second part, if that's gone, has 2 times x minus 1. So x plus 2 plus 2x minus 2, we get x plus 2 times 3x. So x equals -2 from the first one, and x equals 0 is what the final derivative is. We go from -infinity to -2, from -2 to 0, and from 0 to infinity. When I plug in -3, we get a negative times a negative, which is a positive, which means we start out increasing. When I plug in -1, I get a positive times a negative, which is a negative. So we are decreasing. And when I plug in 1, we get 2 positive, which is a positive, and we are increasing. Alright, so for problem number 11, here's what f of x is equal to. We're looking for our relative extrema. So I take the derivative. Times 4x, which means I got 16x times 2x minus 8 to the third power. So we set each one of the factors equal to 0. That's 8. Divide by 2. Don't forget the plus or minus. So we go from -infinity to -2, from -2 to 0, from 0 to 2, and from 2 to infinity. Pick numbers in between our intervals. And so when I plug in -3, this is a negative, and this is a positive, so we start out decreasing. When I plug in -1, we get a negative and a negative, which means we have something that is increasing. When I plug in 1, I get a positive times a negative, which is a decreasing. And when I plug in 3, I get a positive times a positive, which is increasing. So here I have a minimum, here I have a relative maximum, and here I have a relative minimum again. So when I plug in -2, I got the answer of 0 as my relative min. When I plug in 0, I get the answer of 4,096. And when I plug in 2, I get the answer of 0 again. And those are my relative min, relative max, and relative min for problem number 11. So here I need to take the derivative. So x squared, the derivative of that is 2x. X plus 1, the derivative of that is 1. So I have 2x times x plus 1 minus x squared over x plus 1 squared. So we got 2x squared plus 2x minus x squared over x plus 1 squared, which gives me x squared plus 2x over x plus 1 squared. Hello? So when I factor the top, that gives me critical points at x equals 0 and x equals -2. And I also have to worry about the bottom because even though it doesn't exist, it still may change direction. So I'm going to go from -infinity to -2, from -2 to -1, from -1 to 0, and from 0 to infinity. So when I plug in -3, the top turns out to be positive, the bottom is always positive, so that's positive. When I plug in -1.5, the bottom's always positive, and the top has one negative factor and one positive factor, so we got negative. When I plug in -0.5, once again the top is one negative, one positive, which is negative, and when I plug in 1, everything is positive. So here we're going to have a relative max. Here does not exist because -1 is a vertical asymptote and it's not continuous. And here I have a relative min. So I need to plug in f of -2 and I need to plug in f of 0. That one's easy because it's 0 divided by 1. And when I plug in -2, I get 4 over -1, which is -4. And so that is my relative maximum at -2, -4. And my relative minimum is at 0, 0.